Okay, in this video I'm going to finish exercise 4A of the book Fundamental Applied Mathematics. We're on page 99 and the question is 3. It reads, ship T is 100 kilometers due west of ship Q. T is travelling at 10 kilometers an hour in a direction east 30 degrees south. Q is travelling at 20 kilometers an hour in a direction west 45 degrees north. Find in terms of I hat and j hat the velocity of T, the velocity of Q, and the velocity of T relative to Q. Find also the magnitude and direction of the velocity of T relative to Q, and hence find the shortest distance between them in the subsequent motion correct to one decimal place. So I've sketched the motion there, where I have Q going west 45 degrees north and T going east 30 degrees south. In blue I have the unit vectors for T, so T is equal to T sub x I hat plus T sub y j hat, and Q is equal to Q sub x I hat plus Q sub y j hat. However, in this case we know that for Q this is going to be a negative number, and for T this is going to be a negative number because of the direction that they're facing. So let's just resolve these vectors. So we'll say do T first, and we're going to get T times, we'll say T, the vector T is equal to, T was equal to 10, wasn't it? Yeah, so 10 cos 30 I hat plus 10 sine of 30 j hat. Now sine of 30 is a half, and the cosine of 30 is root 3 over 2. So you're going to get, this is root 3 over 2, isn't it? 10 cos 30, just let me check that here. The cos of 30, yes, it is root 3 over 2. So you're going to get 5 root 3 I hat plus 5. So if we do a similar thing for Q, 5 root 3, it'll be 5 root 3 I hat minus 5. So I'll just say T is equal to 5 root 3 I hat minus 5 j hat. Alright, and Q will be equal to, its magnitude is equal to 20, so it'll be 20 times, negative 20 times the cos of 45 plus 20 times the sine of 45. But the cosine and sine of 45 are 1 over root 2. So you can do that, and we're going to get, that's the answer, negative 20 over root 2 I hat plus 20 over root 2 j hat. Like so. So the next thing we're going to do is get the velocity of T relative to Q. T relative to Q. So it's written mathematically as T or VTQ like this, and that's equal to VT minus VQ. Of course, this means that Q is stationary, so that's the one that's not moving. And basically, if you just play around with if you do that, and I'm not going to bother doing it because it's quite simple, you're going to get, let's say, essentially 23 I hat, or excuse me, 19 minus 19.14. So we'll just say, yeah, we'll say 19 j hat. All right, so that's VTQ. Now the next thing we need to do is we need to get the magnitude of the vector VTQ. How do we do that? Well, of course we use Pythagoras, so it's plus x minus y, so it's going that direction, and to resolve it we go like this. Alright, so VTQ sub y, VTQ sub x, it's negative y, positive x. This value is equal to 19, this value is equal to 23, because of course you can't, the negative sign is to give you your direction, and the magnitude will be 19. So what you can say then is that tan, if I call this angle here theta, tan theta is equal to the opposite over the adjacent. And am I doing something wrong there, am I? Let me think now of the opposite. Well, tan of theta, no, that's correct. Sorry, tan theta will be the opposite over adjacent, so it'll be 23 over 19. Or if you call this alpha, it could be tan alpha is equal to 19 over 23. Alright, that's the first thing. So I'll just get rid of that, we don't need that. So, but it's going back to the fact that we have a right triangle. Okay, you can say the fact that VTQ is the square root of the sum of the squares through Pythagoras. So we get VTQ, the magnitude of it, is equal to square root of 19 squared plus 23 to be squared. Alright, and let's just work out what that is. 19 squared plus 23 squared, and root that, get an answer of approximately 29.8, so we'll say 30. So it's approximately 30 units in magnitude. Alright, now the next thing we need to do is get we need to get the angle, and we did that already, so I'll leave it at that. Alright, and the last thing you're asked to do is find the following. It said that find the shortest distance between them in subsequent motion. So let's just go back to the drawing board here and draw what we have. So we have our y-axis and our x-axis making our xy, our Cartesian plane. And we said we got VTQ, which means Q is stationary, and we said that Q is at the origin, and we said that T was 100 kilometers due west. Alright, so this is 100, we'll say. Now the other thing we know is that the resultant vector was, we'll say, 23i hat minus 19j, which means it's going in this direction like so. So what we need to do is find the shortest distance. Now its magnitude as well was, the magnitude of it was, we'll say, 30 units. Now the shortest distance between these two, we'll say between T and Q, is when they are 90 degrees apart, like so, when you have a right angle here. So if we know this is 100, like so, and we need to know the angle here, and if we have this angle, then we're obviously able to get this, because this will be opposite, so it'll be opposite, the opposite times the opposite over hypotenuse will be sine times the sine of the angle. I'm going to call that angle there alpha. Alright, so we'll just get that angle. So we had, well, I didn't work it out, but I suppose we'd best do it. So we had that this was the vector here, alright, and if we resolve it, there's our right angle. This was, alright, and this was 20, well, the magnitude of it was 30 units. And this is VTQ. So this here was 23, and this was 19. And we want to find out this angle here. So we'll say tan of alpha is equal to 19 over 23. Therefore alpha is equal to the inverse tan of 19 over 23. Alpha equals, so shift tan in your calculator for inverse tan, 19 divided by 23, giving an answer of 39.5, so approximately 40 degrees. So this becomes opposite times the sine of 40. Alright, sorry, this is the hypotenuse times the sine of 40, so it's 100. Excuse me. So 100 times the sine of 40 is the shortest distance. So just to get the sine of the angle and multiply it by 100, and we get 63 meters, or 63.6 meters. So let's say 64 meters was the shortest distance between the two of them. It says go within one decimal place, but I'll let you do that. Alright, so that was reasonably straightforward. Thanks for watching. Please pass it on to your friends and subscribe to my channel.